Bismillahirrahmanirrahim. Welcome to the fourth part of the inverse trigonometric function. This is the fourth part. And in the last three parts, we defined the inverse of the sine inverse, cosine inverse, and the other trigonometric function. And also we evaluated some of these inverse trigonometric functions. And also we spoke about the identities for the inverse trigonometric function. In this part, we are going to speak about the composition of trigonometric functions and their inverses. Speak about the composition. Composition means to find the function of its inverse or the inverse of the function. Called composite. So the composition of these trigonometric functions and their inverses starts with the first one. If we have x between -1 and 1, this is the domain as we mentioned before. If x is between -1 and 1, then sine of sine inverse x will give me x, and cosine of cosine inverse x will give me x. Have to be careful about the domain. X is between -1 and 1, then sine composite sine inverse of x will give me x, and cosine composite cosine inverse x equal to x. We say this is composite or composition. The second one, if x is any real number. If x is any real number, then tan of the tan inverse x will give me x. Tan of the tangent inverse x will give me x. Because we know that for the tangent, speak about what is inside. The domain of the tangent inverse, domain of tan inverse, is from -infinity to infinity. So it can be any real number. If I just think about what is inside. Domain of the sine inverse, cosine inverse is between -1 and 1. So this is the domain of what is inside the bracket. Now for the third one, if x equal to or between -π/2 to π/2, this is the domain of the sine. Then we'll have sine inverse of sine x equal to x. And if x between 0 and π, which is the domain of cosine, then cosine inverse of cosine x equal to x. If x between -π/2 to π/2, and this is the domain of the tangent, then tan inverse of tangent of x equal to x. But also we know that the tangent of x, we have some restriction for that one. But since we can take it in general now, if x between -π/2 to π/2, then tangent inverse of tangent of x equal to x. Let's have some examples as direct application for this composition of the inverse and trigonometric functions. In the first one, we need to find the exact value of this cosine of cosine inverse of 1/2. What is inside is inverse function, which is the first one. And see the condition, is it satisfied that x between -1 to 1? We are looking for this value. If what is inside is cosine inverse, then we are looking at this value. Is it between -1 and 1 or not? Because the domain for the sine and cosine, -1 to 1. And this is okay. 1/2 is between -1 and 1. So the cosine will cancel the cosine inverse. I will have 1/2. So the value is equal to 1/2. For the second one, tangent inverse of 2. What is inside is tangent inverse. And the domain for the tangent inverse must infinity to infinity. This is any real number. So this can be equal to 2. Just like we are, this will cancel this one. That is only 2. Next one, 29. Sine of tangent inverse is 3/4. Now tangent inverse of 3/4. This can be written in 3/4. It is like we are looking for the theta, whose tangent is equal to 3/4. Is equal to theta. But we know that 3/4 is equal to opposite over, I can say it is y over the adjacent. So if this is theta, then the tangent opposite equal to 3, adjacent equal to 4, then the hypotenuse will be equal to 5 by Pythagorean theorem. So this is equal to, because we are looking for the sine. Sine equal to the opposite over hypotenuse. So we can do it in this way. It will be 3/5. So sine of tangent inverse 3/4 will give me 3/5. We are not given the angle, but we are given the tangent inverse. So it is like it is sine theta. Or I can write it as sine theta. If we make this equal to theta, then it is sine theta. That will give me 3 over, it is the opposite over the hypotenuse, which is equal to 3/5. Similarly for the 31. 31, this will be, because we know sine inverse of square root of 2 divided by 2 equal to 45. So this is equal to tangent of 45, which is equal to 1. 33, we need to find cosine of secant inverse of 2. But from the identities, we know that cosine of secant inverse of 2, it is 60. So this will give me 60 degrees or equal to pi over 3. For 35, sine inverse of sine pi over 6. If we go back to the compositions, if theta between minus pi over 2 to pi over 2, then sine inverse sine will give me x. So this is direct equal to pi over 6. Sine will cancel the sine inverse. 37. Sine inverse of sine pi over 4. We can do this in 2 steps. It's equal to cosine inverse of sine pi over 4 is equal to 45, which is, I'm sorry, sine pi over 4 equal to square root of 2 divided by 2. So cosine inverse of square root of 2 divided by 2 equal to, again, pi over 4. This is because we know that the sine and cosine are equal when theta equal to pi over 4. Now 39, I need to find sine inverse of tangent pi over 3. Now sine inverse of tangent pi over 3, which is 60. This is 60. Tangent is the opposite divided by adjacent, we have 1/2 and 1/2. So tangent of 60 is equal to, so this will give me sine inverse of square root of 3. Sine inverse of, so I have to find the value of the tangent by over 3. So tangent of 60 equals square root of 3. Now I need to find sine inverse of square root of 3. So we are looking for the theta that its sine equal to square root of 3. This will be approximated value. So we need to find the calculator because this is sine inverse square root of 3 and sine square root of 3. Let's take this value. Now pi over 3 or square root of 3 is approximately equal to 1.7. It is 1.7. Now 1.7, if we go back to see for the sine inverse, sine inverse of sine x equal to x, and the domain of the sine inverse must be between -1 to 1. We said this before. The domain of the sine inverse must be between -1 and 1. But square root of 3 is not between -1 and 1. Square root of 3 is not in the domain of the sine inverse. So this is undefined. We say it is undefined. Because square root of 3 is not in the domain of the sine inverse. Now for the tangent inverse, 41, tangent inverse of sine pi over 6 is equal to tangent inverse of sine pi over 6, it is sine of 30, and sine of 30 equal to 1/2. So we are looking for the angle, which its tangent equal to 1/2. That will be most likely not 45. This will be less than 45 because you know the tangent of 30 equals square root of 3. This is equal to 1 over square root of 3, and so this will be between 45 and 30. We don't have exact value, so theta will be between 30 and 45. We need to use calculator to find this one exactly. For the 43, I need to find sine inverse of cosine minus 2 pi over 3. Now this is equal to sine inverse of cosine minus 2 pi over 3. Cosine minus 2 pi over 3, which is equal to 120 or minus 120. What do you give me? Let's go back and just to check these conditions. And it's sine inverse of sine or sine inverse of cosine. But this is cosine, not sine. What is inside is cosine. Cosine of minus 2 pi over 3. Take it one by one. Cosine minus 2 pi over 3. This is cosine of minus 120. Cosine minus 120, this is in the third quadrant. And the cosine in the third quadrant is negative. Cosine in the third quadrant is negative. So this is equal to minus, but if we just think about the 120, the reference angle will be 60. It is minus cosine 60. That will give me minus 1/2. So cosine of minus 2 pi over 3, which is equal to cosine of minus 120, that will give me minus cosine 60 or minus 1/2. So the sine inverse of cosine minus 2 pi over 3, that will be sine inverse of minus 1/2. Well, what I did, I just find the value of cosine of minus 2 pi over 3, that will give me sine inverse of minus 1/2. This is in the fourth quadrant, or the theta will be negative. This will give me minus 30. Or minus pi over 6. So sine inverse of cosine minus 2 pi over 3 equal to minus 60. I'm sorry, minus 30, which is equal to minus pi over 6 in radian. So this is the application or exercise for the composition of trigonometric functions and their inverses. Similarly, we can do the exercise number 45 and 47. We need to find what is the value of the inside the bracket, then tangent of that inverse or that one. For example, 45, you can find this directly. The tangent of what is inside sine inverse of 1/2 is 30. And tangent of 30, as we did before, equal to the opposite divided by the adjacent, which is equal to 1 over square root of 3, or it is square root of 3 divided by 3.